Okay, so let's do practice problem 16 on page 501. And I'll read the problem out loud. It says a 2.2 microfarad capacitor is first charged so that the electric potential difference is 6 volts. How much additional charge is needed to increase the electric potential difference to 15 volts? So here's kind of how this works. Let me just draw a picture of it. We've got a certain amount of charge on this plate. And that charge creates an electric field in that capacitor. And you didn't have to draw this, but it creates an electric field in there. And it's enough charge so that when you go from here to here, if you're a positive test charge, you're going to drop 6 volts. So this is at 6 volts, and this is at 0 volts. And what we want to do is add charge to it. If you increase the voltage, you increase the pressure, the push on those charges, and you can stuff more and more and more and more charge in there. So you get more and more and more negative charge right here, and you increase the strength of that electric field until you get to 15 volts. And then you stop. You want to know, well, if you increase from 6 volts to 15 volts, how much additional charge did you put on there? Well, let's do it this way. There's several ways to do this problem. I'm going to do it like this. Well, delta Q is equal to the charge on it at the end when you had 15 volts minus the charge that you started with when you were at 6 volts. And these are just little subscripts. I'm not multiplying anything here. I'm just showing a subscript. Okay? You can call this Q final and this Q initial if you want to. Well, how do I figure out what the charge is? Well, capacitance is equal to the charge on the capacitor divided by the voltage difference you get across the plates. Okay? Or the voltage you needed to get that much charge on that capacitor. Okay, now solve for Q. Now, hey, when I graded this, believe it or not, some people are having a little tough time with the algebra here. Okay, don't make little silly mistakes like that. If you're solving for Q, for the charge, just multiply both sides by the voltage. You get Q is equal to C times the voltage across the plate. Okay, so that's what I'm going to do here. The charge, this is going to be C times 15 volts minus C times 6 volts. So this is the charge at 15 volts. This will be the charge at when I'm at 6 volts. Okay, now I'm going to factor out the capacitance, and then the capacitance is 2.2 microfarads, and then I'm going to have 15 minus 6. Now 15 volts minus 6 volts is 9 volts. And so let's see, well, what is 9 times 2 is 18, 19. I move the decimal over once. Keep the micro, and a farad times a volt. What's a farad times a volt get you? Well, we're solving for the change in charge, right? So it's got to be coulombs, but look, what's a farad? A farad is a coulomb per volt. You multiply that by volts, and you get coulombs, see? That's what a farad is. It's how much charge you've got on your capacitor per volt that you put across those plates. Okay, and so now remember, this is delta Q. This is not the final charge that's on the capacitor. This is the additional charge I had to put onto the capacitor to go from 6 volts to 15 volts. Okay, and that's my answer. Okay. Any questions on problem number 16? That is all.